All right, I think we're live. Push one in the chat if you can hear me. All right, got a confirmation from the chat. Thank you for the confirmation. Welcome back to the Black Brain Trust. This is episode 537. Please hit the like button as you come in, share the video if possible, hit that notification bell so you get all the updates from the Black Brain Trust, including those posted on the community tab. Docket and description beneath the video for you to follow along with. If you want to engage in the discussion, there'll be a link in the chat for you to click on. When you click on the link, make sure you raise your hand so that one of us can acknowledge you and advance you to the panel. All right. If you're trying to get into IT for the first time, we do offer IT mentorship here. If you're trying to go from one IT role to another, we do offer IT coaching. If you're trying to figure out salaries, wages, and how to negotiate, as well as cover letters and resumes, we do offer advice in that area. If you're in the New York area or the tri-state area, Nagona 11 does have recs on the table. So reach out to us at the end of the live stream or during the chat, and we'll get started. Give a shout out to everybody who showed up first. Thai City, what it do? Aqua Techie, greetings. Gear Z Net, peace to you as well. All right, let's get started. Oh. All right, first item on the docket is from technologyreview.com. The pandemic is emptying call centers, AI chatbots are swooping in. Brian Pokorny had heard of AI systems for call centers before, but as the IT director of Otsego County, New York, he assumed he couldn't afford them. Then the pandemic hit and the state governor ordered a 50% reduction of all government staff, forcing Pokorny to cut most of his call center's employees. Meanwhile, inbound calls were rising as more residents began seeking reliable COVID-related guidance and medical information. So Pokorny picked up the first solution that landed on his desk, Watson Assistant for Citizens, which IBM has started offering to governments, healthcare organizations, and research institutions in a 90-day free trial. Within days of his signing up, the Watson team helped him deploy a chatbot to address callers' most common questions, such as how to identify symptoms or how to get tested. The software also made it easy for him to update and expand the chatbot's responses as queries evolved. As the coronavirus crisis has dragged on, understaffed government agencies, grocery stores, and financial services have all scrambled to set up similar systems for handling a new influx of calls. IBM saw a 40% increase in traffic to Watson Assistant from February to April of this year. In April, Google also launched the Rapid Response Virtual Agent, a special version of its contact center AI and lowered the price of its service in response to client demand. While call centers have long been a frontier of workplace automation, the pandemic has accelerated the process. Organizations under pressure are more willing to try new tools. AI firms keen to take advantage of sweetening the incentives. Over the last few years, advances in natural language processing have also dramatically improved on the clunky automated call systems of the past. The newest generation of chatbots and voice-based agents are easier to build, faster to deploy, and more responsive to user inquiries. Once adopted, in other words, these systems will likely be here to stay, proving their value through their ease of use and affordability. IBM's and Google's platform work in similar ways. They make it easy for clients to spin up chat or voice-based agents that act like a lot like Alexa or Siri, but are tailored to different applications. When users text or call in, they are free to speak in open-ended sentences. The system then uses natural language processing to parse their intent and responds with the appropriate scripted answer or reroutes them to a human agent. For queries that can't be answered automatically, the algorithms group similar ones together to show the most commonly missed intents. The nice thing about the technology is that it somewhat learns what types of questions are being asked, so we can plug them in. We can program it after the fact, says Porcani. The platforms are proven popular among a range of organizations, especially those with limited technical resources. Small and mid-sized government organizations, including the city of Austin, Texas, and Czech Ministry of Health, have used Watson to build chatbots that provide information about COVID testing, prevention, and treatment. The Oklahoma Employment Security Commission has used Google's virtual agent to help identify over 60,000 daily calls related to unemployment claims. Health providers like the University of Arkansas for Medical Sciences and the University of Pennsylvania's Medical School have worked with both platforms to develop patient triage tools that help them administer timely care. The goal of the systems is to get as many queries as possible answered by the virtual agents before any calls are handed over to humans. This reduces the burden on call centers and the wait times for users. It also reduces the need for expensive human agents. A week in, Procani was impressed. I see us using this technology well beyond the crisis, he says. Right now, his county is using the chatbot only to field COVID-related questions, but he plans to deploy a voice-based version that becomes the first point of contact for anyone dialing in about any issue. Watson's pricing after the free trial is also inexpensive, he says. He demurs about what this means for laid off staff and whether they will regain their jobs after the pandemic. We're fighting this from two angles, he says. One is obviously the health crisis, but once that's over, we're going to have a tremendous economic crisis. I see some artificial intelligence may be helping us. Many other organizations will be facing similar pressures to keep their operations lean. So it's possible that call center jobs already lost may not come back. But perhaps the good news is such jobs won't be eliminated entirely. Algorithms are still far from understanding the full context and nuance of conversation. So rarer cases will have to be reserved for the more capable hands of humans. Some matters are also too sensitive to outsource to AI. Around the same time Procani started using Watson, Children's Healthcare of Atlanta and Georgia began working with IBM Systems to develop a chatbot for helping parents access their children's symptoms. The health center turned to automation after people began innuating their phone lines, cranking up wait times to 30 minutes or even an hour. like Borkani, Chow was impressed by how fast it was, how fast it. This is spelled wrong. How fast the bot was to deploy, and how easy it was to customize so that it replicated the assessment flow that would have been performed by a pedestrian. In just its first week, the application logged 1,000 unique conversations a day. But as much as Chow sees technology's role expanded beyond COVID symptom assessment, the center doesn't see it fully replacing call lines or becoming the first point of contact. It works really nicely during the pandemic time when people really just want some information, says Daniel Hirsch, a physician here. But I work in pediatric emergency medicine in the ER. When parents are nervous about their kids, people want to talk and have a conversation with a human. This is very true. Okay? This is very true. People, when Dell started using, automated systems to replace their call centers during peak times, people were really dissatisfied with these systems because they didn't want to talk to a robot. They wanted to talk to a human. And so what they'll do is they'll push zero. They'll continuously push zero until zero brings them to an operator or some form of human. And so that's what they found. And that's why, a lot of the time you'll notice that companies will drop a AI-based system or a automated call center based system just based off of that and that alone. The dissatisfaction with customer response is exactly why it dies off pretty quickly. And so maybe hiring a human might be worth it, at minimum wage or whatever wage it is, because if you factor in, let's say you lose 100 people a day because of the dissatisfaction with the system, but the cost to actually hire a single human just so that a customer can talk to them is actually fairly minimal. And so AI, despite the fact that it may be cost efficient in some areas, it's still not the exact, it still can't make up for, the lack of human-to-human experience. And that's where, those people will be able to hold on to their jobs, and AI won't be able to come and sweep them out entirely. But as the article is saying, for some people, those jobs are never coming back. And so that's where AI comes in and actually makes sense that when the cost to implement is far cheaper than the cost of a human resource, then you move on to automation and AI, okay? But that happens over time. It doesn't happen overnight. All right, move on to the next document. Item on the docket. All right. This is from HBR.org, Harvard Business Review. Is your data infrastructure ready for AI? Every big company now manages a proliferation of sites, apps, and technology systems for interacting with buyers and managing everything in the business, from customers and clients to inventory and products. These systems are spitting out data continuously, but even after multiple generations of investments and billions of dollars of digital transformation, organizations struggle to use that data to improve customer service, reduce costs, and speed the core process that provide competitive advantage. AI was supposed to help with that, but as an executive at a major life insurance company told me, every one of our competitors and most of the organizations of our size in other industries have spent at least a few $1 million on failed AI initiatives. Why? 20 years of experience working with companies on their information technology have shown me the reason, because promises of AI vendors don't pay off unless a company's data systems are properly prepared for AI. Data is locked in silos, inaccessible, poorly structured, and mostly important, not organized in such a way as to be used as the fuel that makes AI work. Instead, to reap the benefits of AI, companies need to create something called an ontology, a comprehensive characterization of architecture of all its data. This is very true. This is very true. Okay. You may have read advice that you should start with AI initiatives. And it's true, the AI light approach can generate some quick wins, but as AI initiatives inevitably multiply throughout the organization, the limits of scattered experiments become more glaring. When you feed such AI programs with different types of sometimes incompatible data sources, the result will entangle you in a complexity. Soon you'll have a slew of one-off AI pilots connected to your existing data systems in a way that fails to deliver broader, more strategic benefits for your business. AI is far enough along with a more far enough along that a more comprehensive approach is needed, a key that brings together all of your company's data. That's where the ontology comes in. An ontology is a consistent representation of data and data relationships within your business, a model of all elements that go into and connect your various information systems. The products, services, solutions, and processes, organizational structures, protocols, custom characteristics, manufactured methods, knowledge, content, and data, all types. It is the master knowledge scaffolding of the organization. Without consistent, thoughtful approach to developing, applying, and evolving an ontology, AI systems can only develop in a piecemeal, fragmented way. They will lack the underpinning that would allow them to be smart enough to make an impact. The ontology is at the heart of the information design of the AI-powered enterprise. An investment that will continue to pay off as AI becomes more pervasive. Let's look at the B2B service firm Applied Materials and how they developed an ontology that showcases these benefits. Applied Materials works with semiconductor manufacturers to fix problems that slow or halt production at semiconductor plants. Problems that can cost millions of dollars a day until they are remedied. Because until recently, the knowledge to keep a plant running was distributed among 14 different systems within Applied Materials. Technicians spent up to 40% of their time searching for answers. Every plant is unique, so finding the right answer for a particular plant's problem is both essential and challenging. Techs tended to hedge their bets by stocking their service vehicles with a variety of costly components, tying up millions of dollars in inventory. The techs needed a consistent efficient experience, but to build it, Applied Materials needed a way to organize the diverse sources of information available to techs in a way to integrate them into a single interface. The ontology we created for the company included the all. Sorry, this is spelled so badly, grammatically incorrect. All the multiple vocabularies, relationships, and hierarchies in all of those systems the text use. It defined relationships for the short names. One system used to refer to a part, and the stock number, another system used to refer to the same part. We parsed and classified troubleshooting documents with text analytics, a method that learns from a model document, then extracts information from similar documents and makes all the knowledge accessible with a common language. When we were done, we had created a common language with a master set of relationships that connected the information in the data in the company's customer management systems, service ticket tracking systems, database of solutions, parts of catalogs, and all the other systems. Then we had created the ontology. We needed to actually apply it to all the underlying data and connect it to the text experience and make it accessible from a common interface. Once everything was tagged, applied materials incorporated the ontology in multiple systems and processes, applied it to existing documents incorporated it into workflows for new documents, and just lost my spot, got interrupted. And connected it to ERP and digital asset management systems. This enabled us to create the new system we had dreamed of that empowered field techs to get exactly the information they needed efficiently from whatever sources were most appropriate to the task at hand. The logical groups of content organized in ways that aligned with their way of thinking about the problems they were solving, their mental models, helped them locate exactly the information that would be most useful in a given context, like troubleshooting guides. This is actually really, really good. We got Nagon 11 on the panel. Okay, Nagon 11 is not here. Let's go to engineering cannabis. Okay, I don't think anybody can hear me. Engineering cannabis, can you hear me?
Yeah, I can hear you.
What's going on, Mike?
I'm chilling, man. Chilling, man.
Nagon.
All right.
Yeah, step away for a second.
All right. Let me finish this article real quick and then we'll open it up. How to build an ontology. As you might imagine, creating an ontology that will make sense of all your company's data isn't an easy undertaking. Based on many companies, I've walked through the process. Here are the key steps. Number one, identify data pain points. Audit where information problems and bottlenecks are impairing the function of the business, like the applied materials text frustrating solution searches. Look for root causes that are generating multiple problems. This helps people understand how solving the bigger data architecture problem can generate widespread benefits in the enterprise. Number two, generate solutions based on root causes. Start to imagine what a potential solution could look like, such as the more efficient search system, applied materials so sorely needed. Begin with the tasks that will have the biggest impact on the business if made more efficient. Number three, understand use cases. Consider who will benefit from each solution: customer service staff, product developers, or maybe customers on an e-commerce site, and exactly what tasks the solution will help them to perform more efficiently. Develop a model for what the individual must do to achieve their desired outcome. Then validate that by testing it out with actual workers doing their jobs. Learn how they describe the ideal answer, then match up how they describe it with the ways that other workers in other worlds describe the same types of problems. Number four, set the ontology's organizing principles. This is the key to the ontology. With the knowledge about how people are using the information, you can begin to architect the details of how to organize and categorize the data you have to make it part of the solutions you are creating. For example, at Applied Materials, master concepts had names like account, user, business unit, and solution that matched up to a variety of terms within the company's legacy systems and to the mental models that the text had for what was going on any part of the plant. Once you've created an ontology this way, the benefits multiply. It becomes an essential part of not only the solution to today's information problem, but to the next problem that arises and the next. Keep in mind that the ontology is continuously evolving entity as products, services, markets, competitors, and customer needs changes. An international process for changing the ontology will keep it fresh and relevant. It's increasingly clear that AI is going to be solving many of those problems in the future, whether that's by means of a customer service chatbot, a system that surfaces signals about business efficiencies and breakdowns, or any of 1,000 other applications. The ontology, as a representation of what matters within the company and makes it unique, is what unifies those solutions and makes them more than just a quick fix that will just as quickly become obsolete. If you suspect that AI is in the future of your business, the future of business, a conclusion I'm certain of, then creating an ontology is an essential investment to prepare your enterprise to realize the benefits of that future. It's a concept that, managed and applied appropriately, makes the difference between the promise of AI and delivering sustainably on that promise. Yeah, this is really good. Okay. I didn't know there was an actual term for it called ontology, but now it makes a lot of sense. And so when we talk about,
Go ahead.
okay, when we talk about AI, we're not just talking about the application aspect of AI, but there's a whole entire architecture that goes behind AI. You gotta have your data analysts and your data engineers and your cloud compute engineers and your information science people, you know, the data architects, information architects. Those people are very critical in all of your in all of the development of your AI. So AI isn't just one person. You know, it's a collaboration of different people.
Yeah, I agree with this because the 4 points made basically talked about, as I always say, understanding the process, understanding how your business process works, and then automating where the problems are. This article basically just delves into it. That a data scientist is not just coming in and putting algorithms and go. Before you even put an algorithm on the board, you have to understand how the process works. How, for instance, if you go into McDonald's and trying to order a cheeseburger, from the process of going into the building to the process of getting your food, that whole process, where is it easy to automate and remove people and mistakes from? So that's what AI is. How can I look at that whole process from where I'm going to order a burger, come into the place, order a burger, they take my order, cook it, all that, then I receive my food and I make a payment. Where in those places are we lacking? Are we having problems in? And how can we automate it? How can we use data science? How can we use machine learning, deep learning to eliminate jobs, or not eliminate tasks that basically it's not, you don't need, that's inefficient, that you can make it more efficient. And that's what data science is. And companies are moving into that way. So again, if you're trying to understand data science, just understand you're not just going to be looking at an algorithm, a number every day. You're going to have to look at a process. You're going to have to look at how a business functions. Then look at every part of that business, and then look at how can I put an AI, how can I automate that system that's given this problem? Or how can I automate this system? It's inefficient, but how can I automate it? But again, you have to look at the whole process. And that's where machine learning, deep learning, and all that, it's a tool, but it helps for you to look at the big process first.
Yep. Now I know Nagona 11 had a few recs come across his table involving some of these technologies. I don't know if he can speak to it. I don't know if he's available.
Yeah, I'm here. I'm here real quick. I'm just in the middle of doing some stuff. We're just
Okay.
getting the lawn and stuff, getting the front lawn and stuff together. So I've been putting some stuff down there. But right now, what kind of engineering cannabis just said, pretty much it's pretty much right on the money. I don't have any recs in front of me, but that's pretty much to the bottom line as to kind of what we're really talking about. I did have a machine learning job. I think I read online here one time from one of my other companies, and data analysts and so forth. I mean, a lot of stuff is coming up, but the whole business processing piece and really, following the process is bottom line. You're not really going to be able to get around that to be successful in this type of position. Now, there might be some slightly different aspects that they may have specifically for you to do in a role, but it all follows and flows within that platform. That kind of engineering cannabis and what we're talking about right now kind of fits into. So I don't really have much more to add on that. I think you guys kind of are kind of you're walking us down the garden pathway properly.
All right. So ontology is, like I said, it's a new term for me, but it makes sense as to where it applies. And so you got to figure out where do you fit within the team of ontology. Got to understand the data from a raw standpoint, raw data. I think a lot of, in my experience, I think a lot of your Oracle DBAs and your Microsoft SQL guys, those guys are going to be pulled, those people are going to be pulled in to that ontology because they understand the database structure and all the data that's going into it. But they're going to be responsible for structuring out that data correctly. Okay. Those people are going to be very important. They're never obsolete. There's nothing wrong with a old DBA guy who understands select statements and whatnot that can help build out better information infrastructure through database management. We got Renaissance on the panel.
Okay. Right on the money, Mike. That's right on the money. I'm sorry. Go ahead, Renaissance man. Go ahead.
Hey, can everyone hear me?
Put some volume on your mic, bro.
This better?
Yep.
Yeah. I had a quick question. I'm looking at, and Nagone may be able to chime in, and maybe you too, Mike. I'm taking right now a Coursera course on Intro to Data Science, very, very entry level, like what's the definition of data science is, all of that. It's only a 3-week course, about to be finished. I was looking and I saw Harvard had a course which is a little bit longer. Looks like probably, I guess, about 8 modules, something like that, on edX.
Yeah,
I was just wondering.
I took. I'm looking at that. I'm looking at like 7 courses now, Harvard. They're really good.
Okay, no. Do you think that would be that'd be something that, hey, someone with like my degree, my background's in finance, that would definitely be something that you could get a move into that career path?
Yes.
Just with the certification.
Yeah, for sure.
Yeah.
Entry level for sure.
Yeah, most of the people I supported from an IT standpoint in finance were the data science group. Okay, your most entry level person, they had a bachelor's degree, but it was in like statistics or something else.
Mathematics, statistics, linear algebra.
Yeah, they came from that background. They just needed a better understanding of how to actually work a database or how to actually work a system, right? So
Python and all that, how to use Python. How to get the algorithms and all that. Yeah.
Basic linear regression, y equals mx plus b, basic stuff like that. Do you have a degree?
Logistics regression, all that stuff. Yes.
Yeah, he has a degree in finance, right?
Okay, very good.
With that, what I'll say is with the certificate, you can go into the role of a financial engineer. Basically, again, a financial engineer just does what a scientist does with again, algorithms, basically predicting stock stock portfolios based on variables. Again, variables that basically like politics or different kind of variables to predict stock outputs and all that. So yes, you can definitely move into a role if you take the certificate and all that. Yes, you can. But again, you just have to study. It's again, I'm usually for courses that are like 3 weeks or this. I'm usually kind of hesitant about those courses
Yeah,
where
yeah,
you
very
take
much
three
so.
weeks and all that, because remember what they're teaching you right now is just machine learning. They're not teaching you deep learning, or because that you have to learn on your own. I haven't seen anybody teaching that deep learning or natural processing languages. What they're strictly teaching you in that data science, most courses I've seen, is machine learning, how to utilize Python, and basically utilize the algorithms. Again, they're just three classes of all algorithms. Again, classification, regression, and clustering. So they're just teaching you how to utilize those algorithms to make predictive outcomes, and they're teaching you how to utilize Python. So again, most courses I've seen, they only teach you machine learning, and machine learning is what you will need in most industries, especially finance.
Yeah, yeah,
Deep learning is another level.
yeah.
You know,
Keep in mind that these
very,
programs are. Yeah, keep in mind that these programs are really developed for people who are just trying to either budget allocated for continuous learning in the environment, or there's somebody trying to keep just to brush up on their skill set in the time being because they have an
or,
allocated time. So that's
or, or,
usually
or
what
what
those
Mike's talking about, more specifically, is continuing education. You're continuing to kind of beef up. He's dead on the money on that.
yeah
Very good,
that's
Mike.
yeah that's what those programs are usually designed for. So 3 weeks is usually roughly what most companies will allocate for training for a year. So
And that 3 week is not enough. I'm gonna tell you
Oh
right
no,
now.
no. The
So
entry level course that I'm in right now is 3 weeks. The one I saw
yeah,
in Harvard's like it looks
yeah,
like 6 months. I want to
six
say, and it's
months.
about
Yeah, even
That's
that six
exactly
months
correct. That's where you need to be.
in 6 months is still not enough, because on even with me, even though I do it on my job on a day-to-day basis, I still go home and put in 3 4 hours, and because there are new algorithms coming out, there are new ways to place it, and there are new. It's an ever evolving
Okay.
field.
Engineering, what I want to tell him is, yeah, you want that 6 month course because he's right
Yeah,
about things are going to be changing, and you're going to pick a lot of that up if you work with
yeah,
someone literally on the job. You're gonna pick that up. But
yeah,
but the name of the game is to get into that longer, get into the longer classes. It's got the modules in
yeah.
module 1, module 2.
No, the Harvard one is beautiful because
Yeah, yeah,
I've been reading it. I've been
that's
doing through the courses.
that's the move.
They
That's the
have
move.
like they have like 18 courses or 20, but each
Yeah,
one, man, and it's free. The good thing is free, but the certificate is not.
yeah.
But
no,
That's what
taking
I was curious about.
the
and
learning aspect is free, but the certificate you have to pay for it.
and
But
and
It's
and
again,
like
and, and,
500 bucks.
yeah, and
and the
it's
cert
worth it. I won't
test.
tell you. I won't lie to you. From Harvard, the certificate in machine learning is worth it.
well, the thing is, if you do pay for it on your taxes next year when you do your
You can
taxes,
write
You
it
can
off.
write it
you
off.
can write it off.
It's definitely
Oh,
right
that's
off.
true.
Yeah,
Yeah,
so
yeah.
it's worth it,
So
to be honest with you, especially in the financial field, because right now I know a lot of Bank of America, they're looking for a lot of data
they're
scientists,
looking for that. And remember,
data
it's an investment. It's not an expense. It's an investment.
investment. So
So you want to get in there, get in on the ground floor. You will get an entry level position
yeah,
at at a bank. Possibly even at a brokerage. But there are a lot of
yeah.
places that you can definitely get in on ground
And
floor at.
once
Not
you
to be
get
making huge money.
yeah, but
I just want to finish up here real quick. You're not gonna come in and making 90, 100,000 walking through the door. Don't think that. Okay. You're gonna work up to that level. We want to make sure that you manage your expectations properly. But you'll get in there certainly above 50, 60K range. You can get in there like that entry. You definitely gonna get in at a decent level and you'll scale quickly.
and
So
after a year or two, you can,
yeah,
because at that point you can order, you're good at using machine learning and that, because after a year or two
that's right.
you can basically do machine learning quickly on Python or R, and at that point you can go look for a salary that basically benefits what you want. Again, 3 weeks is not enough time to go learn machine learning.
It's under the assumption that he has some form of background already.
Yeah.
Like, that's what those programs are really designed for.
If you have a math background, because all machine learning is based on math, statistics, linear algebra, all of them is based on that. If you have a strong math background or computer science, you can pick it up maybe 3 weeks. But again, I won't say 3 weeks, but maybe 2, 3, 4 months, fine. But if you don't
and a strong
have
math
it,
background. Oh, I'm sorry.
if you don't have that background, go to 6 months or a year, and basically you can get a solid entry job as a data scientist.
Yeah, and still with a strong math background, and we're not talking about differential and integral calculus, but very strong in basic algebra. You know, so some fundamentals in statistics.
Yeah,
that's it. We're not talking about being a supreme math major.
A savant in mathematics. You don't need to be a savant. You really don't.
You're not gonna, because you're not gonna be dealing with integrals, and you're not gonna
the algorithm's already in the library. All you got to do is
and derivative.
Make sense of the data. So the algorithm's already in the library for Python. All that. It's easy to you just learn it. It's easy to come in. The goal is to learn when to use it. What algorithms, when to use what algorithm, when to use a classification algorithm, when to use a regression algorithm, when to use a clustering algorithm. That's where it comes in, how to clean your data, how to implement feature engineering in your data. So that's where all the hard aspect come in. The easy aspect is putting the algorithm, which is already there. It's not difficult. Just place a code and algorithm and your prediction comes in. Is before you put the data in the algorithm, cleaning the data, making sense of the data. What features are you going to put in there? Understanding the process. So that's where the difficulty comes in. Put in an algorithm, that's easy.
All right, let me jump to this next article. This one is from technologyreview.com. And AI can simulate an economy millions of times to create fairer tax policy. We won't be reading this whole thing. Deep reinforcement learning has trained AIs to beat humans at complex games like Go and StarCraft. Could it also do a better job at running the economy? Income inequality is one of the overreaching problems of economics. One of the most effective tools policymakers have to address it is taxation. Governments collect money from people according to what they earn and redistribute it either directly via welfare schemes or indirectly by using it to pay for public projects. But though more taxation can lead to greater equality, taxing people too much can discourage them from working or motivate them to find ways to avoid paying, which reduces the overall pot. Getting the balance right is not easy. Economists typically rely on, so this is behind the wall, so I'm not going to be able to read all of it, but this does make a lot of sense. And I've talked about this probably about a month or so ago about running your society on AI, okay? From a governance standpoint, that it can make better decisions if the right data is being fed to it, okay? Now, maybe not the judicial system in this country, but the tax policy and other governance areas of governance can be run better on top of AI. Government generates lots of data. Go download documents from the government's website right now, including all their libraries and whatnot. There's too much data that's been archived that can actually be fed into a system that would into a machine learning system that would actually generate better results from the AI itself if it had to do it. So I don't know, engineering canvas, do you have anything you want to add to that?
Well, I agree with you because, again, the government knows the power of data. We have organizations, the Oceanographic Organization that keeps data on the climate change. We have finance sector that keeps data, decades of data of financial changes. And so the government knows how important data is. And
Mhm.
yes, you can use a machine learning AI. You, again, for instance, you can see in the previous election, we saw how data was basically powerful in manipulating, basically allegedly manipulating, let me just say allegedly manipulating results, Facebook and all that. We've seen how powerful that data is in influencing politics. So it's the same. AI has that influence. AI, machine learning, all that, they have that influence. The ability to influence thought or to do a lot of aspects of that's still ongoing right now. So it's a powerful tool. Again, it's a tool. Knowing how to utilize that tool, that's where that's the expertise. That's where it comes in.
Now, Renaissance Man, did you already finish the course or are you just starting it?
Are you talking about the intro level one or the Harvard one?
The entry level one.
The entry level one, I'm literally, I think I'm in week 2 of week 3. So like I said, it's very basic. Like it just literally, like I said, definition of data science,
Okay.
talks about kind of what they do day to day. It's by IBM.
So they define unsupervised, supervised, all that type of unsupervised, supervised reinforcement and all that. Did they define those
Not really.
variables?
They really
Features?
just talked about like machine learning, deep learning,
They
AI
define,
going with it.
yeah. Did they define what those are? Because it, like what machine learning how it differs from deep learning and all
Yeah,
that.
yeah, they went a little bit into like neural networks and basically,
Yeah,
yeah.
weighted averages, neural networking, yeah, yeah. They, yeah, they're giving you the basics. They're just giving you the definition. When
Yep.
you start actually programming it, then you see how the machine learning and deep learning differs. When you start, because even with the deep learning, there are a number of algorithms within deep learning, like there are a number of algorithms within machine learning. So you got, again, when you're using a deep learning application, you have to when you want to basically differentiate between a 4D to a 2D to a 3D, there are different equations that you have to use for a deep learning equation. So again, the IBM gives you that basics. The 8-week course, I think it's on only on R. I think the 8-week course it's not on Python. It's on only on R for Harvard. It's not based on Python. It's based on R, which is a
Yep.
good language. But again, I'll say Python is predominantly what's being used right now, but R comes second. But again, the Harvard just focuses on R, and then but you can transfer that knowledge into a Python base. That's not difficult. But yeah, the Harvard is great. And I think the Harvard gives you more insights on programming and when to know how to use a machine learning, when to use a machine learning algorithm, when to use a regression, when to use a logistics, when to use a different kind of algorithm, when to use it, and how to use it. So the Harvard is more in depth. I think the IBM just again gives you just a brief definition. And usually I always tell people if you're going to brief use it, there's a book that basically everybody uses. It's called the 100-page machine learning. That book has basically, I think, more insights than the IBM course
Oh, really?
itself.
Okay. You said 100.
It's called the 100-page machine learning book.
Okay. Now I
That's
have to look that up.
that book has everything that defined and tells you, even gives you a cheat sheet on when to use what algorithm and all that. So it's a good book.
Yep. Just found it on Amazon.
Yeah.
Yeah, no, the course was good because, like I said, I had heard about machine learning and all that kind of in passing, but never really gotten some sort of insight. So,
Yeah.
it was sort of saying that, it's very with data science and all of that, it's basically interdisciplinary, that you have people who come from stats backgrounds,
Everybody from
computer
sociology.
science.
Yeah. Everybody from sociology. I know people with sociology background. Every background comes in to learn but they learn machine learning. Then if once you learn machine learning and you want to go further, then you start learning how deep learning works, how natural processing language works. That's when you want to go further. But most people start with machine learning and go from there. And I always tell people, if you want to go into this field, before you jump into it, why do you ask yourself why you want to jump into it? Because it's not a easy course. It's not an easy subject to learn. So I always say, people, before you jump into it, ask yourself why do you want to learn it. If it's for a job, admirable. If it's for something else, also. But you need to know why. Mine, I have certain projects I feel like this aspect will help. That's why I jumped into it and I got really interested in it. So again, before anybody jumps into it, they need to ask that question why, because you're not just gonna spend 6 months and think you learned everything.
Oh yeah,
I
definitely.
continue learning every day. I spend 2-3
Yep.
hours every day reading, researching papers, researching different aspects, learning new algorithms, because I have a goal. Again, don't jump. This is not something you can pick up and say, I learned it in a day, I'm good. It's not that easy. You will
Yeah,
always learn and learn and learn. So if you're gonna pick this up, you need to ask yourself why. It's not something you pick up easily. It's a difficult subject to pick up. But if you learn it and you learn it well, you can see how it applies to every industry you can think of. But
yeah. For
again,
me, the big thing that really attracted me to it, they were talking about how many like when you get to the C-suite, how many executives don't have any experience with like data based decision making,
yeah,
and also just like how you can sort of hypothesize in the sense, like for example, they gave the example of they were looking at the Toronto transit system, and they were basically looking at their complaints, and the data science who was reviewing the data, they're basically, he said, hey, here's all this data, tell me something, interesting or something that actually
tell me a
helps.
story. Tell me a story from all this
Yep.
data.
Create a story out of it.
Yes,
Create a story. Tell me
exactly.
that story. And that's what it is. There's always a story being told from that data. Tell me a story.
And it's
Yeah,
yeah, so it was interesting seeing him go and sort of figure out, well, what's a good hypothesis, what do I think this is, and he
Yeah.
finally figured out on, oh, people are complaining because of the weather on these days, so that's what's
Yeah.
driving your complaint, so you can't do much about it there, but here's your answer. So
yeah,
Yeah. So
yeah.
yes.
All of these minor, minor data points actually start to aggregate and make sense.
Yeah.
Um, the weather that day, what happened that day politically, what tragic event happened. They notice in the Black community, for example, violence goes up during the summer than the winter for obvious reasons. People are more in the house, but in the summertime, um, in predominantly Black neighborhoods, the temperature is actually 10 degrees hotter because there's lack of vegetation.
oh wow, never knew. See, those are the things that, like, that's what attracts me to something like big data, is just because there are all these basically underlying things that we know nothing about, that you have all these assumptions, and it's like it shatters all these old myths, and all of a sudden you have this big tool where you can actually go make substantial change.
And the
10
degrees
degrees, 10
with the
degrees.
data, go
Yeah.
ahead.
No, I was just going to say 10 degrees is a lot for a human being to sustain. I mean,
Oh
one
yeah.
degree might be, 1 degree difference might be, okay, you can add that to the error of margin, or the margin of error. But 10 degrees, you're talking about going from 90 degrees in the summertime to 100 degrees just in one area, with people who lack, the proper environmental, features to reduce that humidity.
It can't be the difference between life and death.
Yeah,
That's the difference between life and death.
yeah. I'm gonna bust a cap in here. That's how hot it is.
I'll put a hot one in you.
Crazy, crazy.
And with the data science, the one question that always comes out is why? Why is this way? Why are we going this way?
Mhm.
You keep asking why till that data makes sense.
Yep.
And that's what I always do. Till that data becomes a story and you keep asking, why, till you get to that root cause, which one of the articles keeps saying. The data will lead you to a root cause, and that root cause will be where your final why will be. So again, the goal is for your data to lead you to the root cause of a problem. For if you're automating a company, what's the root cause of why you need to automate that part of the company? So the why is always going to be important in terms of, again, analyzing, interpreting data, predicted data, why. So again, when I say if you want to enter machine learning and all that, you can do it. It's fun. It's interesting. But again, you need to ask you need to ask yourself, why are you doing this? It's not something you're going to study in one day. It's an everyday study. Every day I'm thinking of how to apply a machine learning algorithm to this sector. How can I use deep learning in the telehealth sector? How can I design a program to do this? I'm always thinking of why. That's why I'm doing this, because I know the application is numerous and I can apply it to different ways and generate something. Again, you jump into it, you need to ask yourself, why are you doing this?
Yeah, let me, there's a question in the chat from Rose Golden 07. So is it best to start with ML, machine learning, then deep learning?
Yes, machine learning, I'll say start with machine learning. Machine learning gives you that, you basically, you start learning how to use algorithms. You start learning how to analyze, take data, and then basically feed the data into an algorithm and then generate prediction. Then you can move to deep learning, where deep learning, you're not feeding data. You're not teaching your algorithm to recognize data. So you're using weighted averages, you're using you're using neural networking to teach your algorithm to recognize your data. So I'll say start with machine learning, learn the basics, learn how the algorithm is generated, learn which algorithms you can use, then go to deep learning, where you then learn how to train a data algorithm, how to train an algorithm to basically, for instance, if you want to train an algorithm to recognize the picture of a cat, that's what you do. You train it using neural networking, weighted averages, and again, Python is a very powerful tool for that, Keras and all that. So again, start with machine learning, learn how to generate an algorithm, learn the mathematics behind it, the statistics, Bayes' principle, learn all that, then go into deep learning. I'll say this, any course you have there always starts with machine learning. No course I've ever seen go straight to deep learning. Every course I've seen starts with machine learning, then
That's,
move to deep learning.
yeah, that's because machine learning, all the other aspects of deep learning, reinforcement learning, natural language processing, NLP, AI are all subsets of machine learning.
Machine learning, yes.
Yeah, they're abstract of it. So you always start off with ML and then you kind of branch off to everything else at the end. Any rigorous course is going to have a structured plan for how you're going to tackle all of these assets in terms of learning the discipline. So I think there is a kind of a scientific approach to how they, how this is how this is learned. Basically, you don't choose which one. You actually go by the structure itself. Let me get to this article from Wired.com. Watson's creator wants to teach AI a new trick, common sense. We were just talking about that. David Ferrucci, the man who built IBM's Jeopardy playing machine, Watson is explaining a children's story to his new creation. In the tale, Fernando and Zoe buy some plants. Fernando places his plant on a windowsill while Zoe tucks hers away in a darkened room. After a few days, Fernando's plant is green and healthy, but the leaves of Zoe's have browned. She moves her plant to the windowsill and it flourishes. A question appears on the screen in front of Ferrucci. Does it make sense that Fernando put his plant in the window because he wants to be healthy? The sunny window has light and the plant needs to be healthy. The question is part of an effort by Ferrucci's artificial intelligence system to learn how the world works. It might be obvious to you or me why Fernando, or to me why Fernando put his plan in the window, but it is surprisingly difficult for an AI system to grasp. Ferrucci and his company, Elemental Cognition, hope to fix a huge blind spot in modern AI by teaching machines to acquire and apply everyday knowledge that lets humans communicate, reason, and navigate our surroundings. We use common sense reasoning so often and so easily that we barely notice it. Ernest Davis, a professor at NYU, who has been studying the problem for decades, says common sense is essential for advancing everything from language understanding to robotics. It is central to most of what we want to do with AI, he says. Davis says machines need to muster fundamental concepts like time, causality, and social interaction in order to demonstrate real intelligence. This is the large obstacle that the current approaches are having serious problems with, he said. The latest wave of AI advances built on a mix of machine learning and big data has given us gadgets that respond to spoken commands and self-driving cars that recognize objects on the road ahead. They are amazing, but they have zero common sense. Alexa and Siri can tell you about a species of plant by reciting from Wikipedia, but neither seems to know what happens if you have one in the dark. A program that's learned to recognize obstacles on the road ahead doesn't typically understand why it's important to avoid people than traffic cones. Because these are moral aspects, in my opinion. These are based on morality. Robots don't understand morality at all. Back at Ferrucci's computer, the researcher clicks an on-screen yes button in response to the question about Fernando's plan. On a server somewhere, an AI program known as Clara adds that information to a library of facts and notions, a kind of artificial common sense knowledge. Like an endlessly inquisitive child, Clara, which stands for Collaborative Learning and Reading Agent, asks Ferrucci another question about the plant story, then another and another, attempting to understand why things unfold the way they do. Can we ever get machines to actually understand what they read, he says. That's a very hard thing, and that's ultimately what elemental cognition is about, which is what engineering cannabis was speaking to earlier, the constant inquiry about why when it comes to data. That's the whole purpose of it. You gotta ask the questions in order to get the better story. Ferrucci has been working at the problem for some time. A decade ago, when he led the development of IBM's Watson, having a computer answer Jeopardy questions seemed near impossible. Yet in 2011, Watson crushed several human champions in a widely publicized version of the show. Watson parsed reams of text to find nuggets of trivia suggesting answers to Jeopardy questions. It was a crowning achievement for AI, but the absence of any real understanding was all too apparent. On live TV, for example, the machine responded to a clue in the category of US cities with "What is Toronto?" Ferrucci says Watson's limitations and the hype around the project propelled him to try building machines that better understand the world. IBM has since turned Watson into a brand that refers to a bewildering range of technologies, many unrelated to the original machine. A year after the Jeopardy match, Ferrucci left to form Element Cognition. It has so far been funded by Bridgewater Associates, a hedge fund created by Ray Dalio that manages roughly $160 billion and 3 other parties. Elemental Cognition operates on Bridgewater's campus in lush woodland overlooking a lake in Westport, Connecticut. Not long after Watson's triumph, AI was transformed. Deep learning, a means of teaching computers to recognize faces, transcribe speech, and do other things by feeding them large amounts of data, emerged as a powerful tool, and it has been applied to even more ways. over the past couple of years, deep learning has produced striking progress in language understanding. Feeding a particular kind of artificial neural network, large amounts of text can produce a model capable of answering questions or generating text with surprising coherence. Teams at Google, Baidu, Microsoft, and OpenAI have built larger, and more complex models that are progressively better at handling language. And yet these models are still bedeviled by a lack of common sense. For instance, Ferrucci's team gave an advanced language model the story involving Fernando and Zoe and asked it to complete the sentence. Zoe moves her plant to a sunny window soon, failing to grasp the notion that plants thrive in sunlight. It generates a series of bizarre endings based purely on statistical pattern matching. She finds something not pleasant. Fertilizer is visible in the window and another plant is missing from the bedroom. Clara aims to go further by combining deep learning techniques with more old-fashioned ways to building knowledge into machines through explicit logical rules, like the fact that plants have leaves and need light. It also uses statistical method to recognize concepts like nouns and verbs in sentences. It also has a few pieces of what's known as core knowledge, like the fact that events happen in time and cause other things to happen. Knowledge about specific subjects is crowdsourced from mechanical Turkers and then built into Clara. This might include, for example, the light causes plants to thrive and windows allow light in. In contrast, a deep learning model fed the right data might be able to answer questions about botany correctly, but it might not. I'm not going to read this whole thing because I think we get the gist of this. You need to give AI common sense in order to have a full conversation, which is part of this problem. And I think, Engineer Canvas kind of hit on this earlier, but a lot of the times when an AI cannot answer or complete a sentence is because they lack sufficient information or knowledge on a particular subject. So the idea about Zoe leaving the plant in the dark and why Fernando left it on the windowsill, had the AI known that plants need light, they would actually have a better response, right? But it didn't have that. And so it's not the fault of the AI, it's the fault of whoever is who fed the data and the information to that AI to begin with. It's insufficient. If you ask me a question about, why did, Toyota's Camry have accelerator issues, I probably wouldn't be able to tell you because I don't really know the internal workings of Toyota and the vehicle itself. We just know we had an accelerator issue. That's all we know. So the AI, we can bash the AI, but we can also bash ourselves for not knowing certain things as well.
Yeah, we're trying to make AI like a magical instrument. AI is a tool. It's like a carpenter who uses a hammer. He has to know when to use it, it's just a tool. Again, AI machine, all are just tools. And we cannot expect machine learning and AI to think like a human. We have not reached that stage. But again, it's a powerful tool that can do a lot of things, automate, predict, but it cannot think like a human. It's not the perfect computer. Again, it's just a tool that can help even humans process information, help humans understand how the world works. That's what it is. It's a tool, nothing more, nothing less.
Yeah, definitely.
That's where we should focus on it. We shouldn't focus on it as something else other than a tool.
Yeah. Renaissance man, you were going to say something?
No, nothing.
Okay. All right, next item on the docket from Forbes.com, artificial intelligence is driving a silicon renaissance. The semiconductor is the foundational technology of the digital age. It gave Silicon Valley its name. It sits at the heart of the computing revolution that has transformed every facet of society over the past half century. The pace of improvement in computing capabilities has been breathtaking and relentless since Intel introduced the world's first microprocessor in 1971. In line with Moore's law, computer chips today are many millions of times more powerful than they were 50 years ago. Yet, while processing power has skyrocketed over the decades, the basic architecture of the computer chip has, until recently, remained largely static. For the most part, innovation in silicon has entailed further miniaturizing transistors in order to squeeze more of them onto integrated circuits. Companies like Intel and AMD have thrived for decades by reliably improving CPU capabilities in a process that Clayton Christensen would identify as sustaining innovation. Today, this is changing in dramatic fashion. AI has ushered in a new golden age of semiconductor innovation. The unique demands and limitless opportunities of machine learning have, for the first time in decades, spurred entrepreneurs to revisit and rethink even the most fundamental tenets of chip architecture. Their goal is to design a new type of chip purpose-built for AI that will power the next generation of computing. It is one of the largest market opportunities in all of hardware today. For most of the history of computing, the prevailing chip architecture has been the CPU, or central processing unit. CPUs are ubiquitous today. They power your laptop, your mobile device, and most data centers. The CPU's basic architecture was conceived in 1945 by the legendary John von Neumann. Remarkably, its design has remained essentially unchanged since then. Most computers produced today are still von Neumann's machines. The CPU's dominance across the use cases is a result of its flexibility. CPUs are general purpose machines capable of carrying out effectively any computation required by software. But while CPU's key advantage is versatility, today's leading AI techniques demand a very specific and intensive set of computations. Deep learning entails the iterative execution of millions or billions of relatively simple multiplication and addition steps. Grounded in linear algebra, deep learning is fundamentally trial and error based parameters. Parameters are tweaked, matrices are multiplied, and figures are summed over and over again across the neural network as the model gradually optimizes itself. This repetitive and computationally intensive workflow has a few important implications for hardware architecture. Parallelization, the ability for a processor to carry out many calculations at the same time rather than one by one, becomes critical. Relatedly, because deep learning involves the continuous transformation of huge volumes of data, locating the chip's memory and computational core as close together as possible enables massive speed and efficiency gains by reducing data movement. CPUs are ill-equipped to support the distinctive demands of machine learning. CPUs process computations sequentially, not in parallel. Their computational core and memory are generally located on separate modules and connected via a communication system bus with limited bandwidth. This creates a choke point in data movement known as von Neumann bottleneck. The upshot is it is prohibitively inefficient to train a neural network on a CPU. The inability of conventional chips to handle modern AI algorithms is all the more significant given how prevalent machine learning applications are becoming throughout society. As AI great Jan LeCun recently said, if you go 5-10 years into the future and you look at what do computers spend their time doing mostly, I think they will be doing things like deep learning. To this point, the chip has powered the AI boom. To this point, the chip that has powered the AI boom is the GPU. The GPU architecture was invented by NVIDIA in the late 1990s for gaming applications. In order to render computer games, detailed graphics at high frame rates, GPUs were purpose-built for continuous manipulation of large amounts of data. Unlike CPUs, GPUs can complete many thousands of calculations in parallel. In the early 2010s, the AI community began to realize that NVIDIA's gaming chips were in fact well suited to handle the types of workloads that machine learning algorithms demanded. Through sheer good fortune, the GPU had found a massive new market. NVIDIA capitalized on the opportunity, positioning itself as the market-leading provider of AI hardware. The company has reaped incredible gains as a result. NVIDIA's market capitalization jumped 20-fold from 2013 to 2018. Yet, as Gartner analyst Mark Hung put it, everyone agrees that GPUs are not optimized for an AI workload. The GPU has been adopted by the AI community, but it was not born for the AI community. In recent years, a new crop of entrepreneurs and technologists has set out to reimagine the computer chip, optimizing it from the ground up in order to unlock the limitless potential of AI. In the memorable words of Alan Kay, people who are really serious about software should make their own hardware. Interesting. 5 AI chip unicorns have emerged in the past 24 months. Several more upstarts have snapped up at eye-popping valuations. As a legacy CPU incumbent seeking to avoid disruption, Intel alone has made 2 major acquisitions in the category. Nirvana Systems bought for $408 million, and Habana Labs bought for $2 billion. As this race plays out in the coming years, many hundreds of billions of dollars of enterprise value will be up for grabs. And so I'm not going to read this whole thing because it's not really necessary, because when it comes to machine learning, deep learning, reinforcement learning, the CPUs that we have today are really the bottleneck in terms of what kind of results we're getting. So I've heard several people say, they're not really impressed by the AI system because, or the AI because it's not quick enough. It's not fast enough. It doesn't do things in real time like they want it to do. But that's not the fault of the AI itself, but it's the fault of the chips that they ride upon.
Yeah, I was going to say in the course I was taking, it touched on a little bit of the fact that like neural networks and things like that have been around for a long time. It's just that they haven't had the computing power. And they were talking about how the cloud was basically enabling them to basically use use the neural networks now by sending it to multiple processors, multiple computers across the cloud. That's how they're doing it, at least right now.
Yep.
Yeah.
Aggregating.
I love the article because it defined how deep learning works in terms of neural networking, and the problems, especially with when you're doing a deep learning algorithm, when you're trying to layers of neural networks, you have problems again with overfitting, underfitting, and basically processing speed, and how the algorithm basically generates, how the algorithm processes data itself, again through the neural networks. And he even talked of optimization and weighted average. So the article it's brilliant, and most of the aspect again with dealing with how the algorithm is processed, how the deep learning is usually dealt with the data engineer. And usually the data engineer they consult with the data engineer to work on the processing speed. That's why individuals who are doing DBA or that, I always tell them, look into the data engineering aspect, because that's another aspect of the big data career path, data engineer. With that, they work directly with the data engineer to deal with these kind of issues. Again, pipeline issues, storage issues, processing issues. So again, I always tell people, look into the data engineering. That's a huge career field too, with the data science and everything. And the article is on point. We do have problems with processing speed. We do have problems in generating algorithms with deep learning equations, especially with neural networks, with different layers and all that. So they're huge issues.
Mhm.
Again, that's why we work with data engineers and all that to basically help with those kind of issues too.
Mhm.
And it's difficult, but again, with problems come solutions, and with solutions comes profitability. So
All right, next item on the docket is from TechCrunch. The future of deep reinforcement learning are contemporary AI superheroes. This is interesting. This is very long. I'm not going to go through all of it. I'll just give you bits and pieces of this. It was not long ago that the world chess champion Gary Kasparov lose a decisive match against a supercomputer. IBM's Deep Blue embodied the state of the art in the late 1990s when a machine defeating a world human champion at a complex game such as chess was still unheard of. Fast forward to today, and not only have supercomputers greatly surpassed Deep Blue in chess, they have managed to achieve superhuman performance in a string of other games, often much more complex than chess, ranging from Go to Dota to classic Atari titles. Many of these games have been mastered just in the last 5 years, pointing to a pace of innovation much quicker than the 2 decades prior. Recently, Google released work on Agent 57, which for the first time showcased uh, superior performance over existing benchmarks across all 57 Atari 2600 games. The class of AI algorithms underlying these feats, deep reinforcement learning, has demonstrated the ability to learn at very high levels in constrained domains such as ones offered by games. The exploits in gaming have provided valuable insights for the research community into what deep reinforcement learning can and cannot do. Running these algorithms has required gargantuan compute power, as well as fine-tuning of the neural networks involved in order to achieve the performance we've seen. Researchers are pursuing new approaches such as multi-environment training and the use of language modeling to help enable learning across multiple domains. But there remains an open question of whether deep reinforcement learning takes us closer to the mother lode, artificial general intelligence in any extensible way. While the talk of artificial general intelligence can get quite philosophical quickly, deep reinforcement learning has already shown great performance in constrained environments, which has spurred its use in areas like robotics and healthcare, where problems often come with defined spaces and rules where the techniques can be effectively applied. In robotics, it has shown promising results in using simulation environments to train robots for the real world. It has performed well in training real world robots to perform tasks such as picking and how to walk. It's being applied to a number of use cases in healthcare, such as personalized medicine, chronic care management, drug discovery, and resource scheduling and allocation. Other areas that are seeing applications have included natural language processing, computer vision, algorithmic optimization in finance. So what is deep reinforcement learning? I'll go over this real quick. If you've navigated the coin maze, your brain at an abstract level has been using reinforcement learning to help you figure out the lay of the land by trial and error, ultimately leading you to find a way out. Reinforcement learning involves an agent exploring an environment many times over, gradually learning which actions it should take in different situations in order to achieve its goals. Its reliance on exploration and learning by trial and error make it very different from other forms of machine learning, which consists of supervised and unsupervised learning. Supervised learning involves learning from a training set of labeled examples, such as labeling 1,000 pictures of dogs and then having algorithm identify whether a new photo shows a dog. Meanwhile, unsupervised learning involves learning from the underlying structure of unlabeled data, such as having an algorithm cluster of 1,000 unlabeled photos containing either a dog or a cat divided into two groups and letting it learn to cluster them based on animal type. This is what engineering cannabis was referring to about a half hour ago. In recent years, deep learning techniques using neural networks have been used in conjunction with reinforcement learning, resulting in a novel approach called deep reinforcement learning. Neural networks can better model high-level abstractions during the learning process, and combining the two techniques together has yielded state-of-the-art results across many problem areas. Let's get slightly more technical, though. To understand the nuances here, reinforcement learning algorithms are typically modeled as a Markov decision process with an agent in an environment as modeled in the diagram below. Engineering cannabis, do you understand this?
Yeah, it's just telling you. Normally, what I usually use is like when a race car is running through a race course. Each time the race car hits, basically stumbles into a dent or something, he learns from it. Then when you start over again, he learns that I can't hit that dent. I have to avoid that dent. So basically, till he runs through the race course, he's going to avoid every obstacle. So that agent is that obstacle. The environment is the race car. So the agent is just that race car is just trying to learn how to navigate through that race course without hitting any obstacle. So again, the goal is to if you go to competitions like where they're using two race cars that's automated to run through a race course. Each time the car hits an obstacle, he learns that there's an obstacle there. I'm not gonna go through that. Then he navigates that obstacle until he navigates through the whole course. And that's what reinforcement learning is. Learning from your mistakes and learning you can't do that anymore. So that's what the reinforcement learning is. Basically, again, it utilizes both machine learning and deep learning. But again, the goal is the agent is just to go make those mistakes and know that I can't make that mistake again. I've learned from it. And I'm not going to make it again and go through it. So that's the best example I usually use when I'm doing reinforcement learning.
All right, thank you for that. How OpenAI and Google's DeepMind are actively beating humans. Games have been a popular test bed for much of the early work on deep reinforcement learning. Games tend to have constrained environments with explicit definitions of rules, and they also typically have numerical ways to track performance. They also harbor the complexity needed for intelligent systems to be able to achieve higher levels of performance over existing benchmarks. OpenAI, founded by Elon Musk, Sam Altman, and others, showed promising results playing Dota 2, a complex strategy game, over the course of the multi-year project, which culminated with their system beating Dota 2 world champions last year. Google's DeepMind's recent results with the Agent 57 project were based on state-of-the-art improvements made to a system they've been building to play Atari games since 2012, when they first proposed a novel deep reinforcement learning approach that involved a neural network called DQN. Previously, the team had demonstrated the ability to surpass top-level human players in both Go and chess with the AlphaGo project and its extended version, AlphaZero. Beyond these projects, they've also shown promising results in playing Capture the Flag. I'm not going to read this whole thing. Reinforcement learning, deep reinforcement learning. Again, I mean, we've covered this before, but these are the abstracts of machine learning. So in order for you to understand deep reinforcement learning, you got to understand machine learning as a whole, first and foremost. Pretty good article, though. It's pretty long.
Yeah, the article is great. It basically tells you where basically it gives you that the whole deep learning and machine learning is applicable to any industry, and basically, again, it's going to be used again from trucking to any industry. The ability to utilize this technology, I'm seeing it in vast ways. Again, I'm looking into telehealth, looking into security. I'm looking into different areas, and you can see the application. And with deep learning and all that, and also utilize blockchain. So the application is, I mean, it's out of this world if you understand it and know how to utilize it.
All right, this is from O'Reilly. Machine Learning with Scikit-Learn, Introduction to Machine Learning. So if you're not a member of O'Reilly, you should go over there and actually sign up for a subscription. I think it's like $400 a year or something like that. It's pretty good. Let me read this real quick. What's a Jupyter notebook? This notebook will cover the basics of Scikit-Learn, a popular package containing a collection of tools for machine learning written in Python. The first notebook in the series covers the basics of two key concepts. What is machine learning? How do you do basic machine learning in Scikit-Learn? These provide the background required to understand the deeper dives into machine learning methods that we will see in later parts of the series. By the end of this notebook, the viewer will have an intuitive understanding of the basic categories and tasks of machine learning, understand the data layout expected in Scikit-Learn, understand essential features of Scikit-Learn's API and how they are used in the case of simple data sets. See one example of how these API features can be used together to gain insight from a more complicated data set. So my first time ever hearing about, well, not my first time, I've come across a Jupyter notebook a few times myself. Let me see.
I use Jupyter Notebook every time because it's a good API. And with Scikit-Learn, the libraries, NumPy, Pandas, oh man, and Matplotlib. Wow, you can do a lot because I use Jupyter every time. I just put Jupyter on my and bring up all my files. It's easy to upload files from there. If I'm looking for a data file set, it's easy to upload it. I mean, it's a very powerful tool. Scikit-Learn, and again with Jupyter, that basically it's basically a structure for Python. You can write all the Python languages there, run it, It gives you all your information. You can run your algorithms in there. It gives you information. It's a very, very, very powerful tool. Again, you can run all your libraries in there, TensorFlow, Scikit-learn, Keras, all that. You can run it, and that's what I use basically to run my Python codes and all that, and it's powerful.
All right. All right, this is from Towards Data Science.com. Python versus R, which is good for machine learning? I think this is where our Renaissance man comes in. If you want to build a machine learning project and are stuck between choosing the right programming language to build it, you know you have come to the right place. This blog will not only help you understand the difference between the two languages, namely Python and R, but also help you know which language has an edge over one another in multiple aspects. So without wasting a single moment, let's dive into it. R and Python both have identical features and are highly popular tools among data scientists. Around 69% of developers use Python for machine learning as compared to 24% of the developers using R. Both are open source and therefore are free in the market. However, Python is structured to be a widely used programming language, while R is created for statistical analysis. AI and data analysis are two territories where open source has become nearly the true permit for inventive new instruments. Both the Python and R dialects have created strong environments of open source devices and libraries that help data scientists of any aptitude level all the more effectively performing scientific work. The differentiation between machine learning and data analysis is comparatively fluid. However, the primary thought is that machine learning organizes prescient exactness over model interpretability, while data analysis underlines interpretability and factual surmising. Python, being increasingly worried about persistent exactness, has built up positive notoriety in machine learning. R, as a language for a factual deduction and statistically inference, has made its name in data analysis. That doesn't mean to categorize either of the languages into one class. Python can be utilized adequately as a data analysis instrument, and R has enough adaptability to accomplish some great work in machine learning. There is a vast number of bundles for the two dialects that look to reproduce the usefulness of the other. Python has libraries to help its ability for measurable induction, and R has bundles to improve its predictive precision. Now, Engineer Canvas, you use both Python and R. Most of the people that I know that are involved in data science use both. Why do you have to make a choice?
It just depends, because I started with R before even data science. I usually use R to do statistical analysis and all that. Then I moved to Python. But most data scientists I know use both, and I don't see. I think the differentiation is basically based on the company you're working for. If the company you're working for basically works with Python, and you have data engineers, software engineers who on the back end use Python, they usually just say, hey, why not just utilize Python as a data scientist, work with everybody to be consistent. But in my own perspective, they both do the same job, and they do it basically bad. They do it the same way. So I don't see the difference. So I use both, but in terms why now I started using Python, because I started programming drones and also blockchain. So again, that's why I was shifting to more of Python, because of the programming side for the drone technology and blockchain. Then I started, okay, since I'm already utilizing in data science and AI, and I can adapt with drone technology and with blockchain. So I said, okay, Python. But in terms of data science, machine learning, both are two powerful tools, and I don't see the difference.
All right. I wonder if there's a difference in versioning for Python though, like Python 3.7, version 3.7. I don't
Yeah,
know.
I think one of the aspects of, again, is Python has, extensive libraries, especially when I'm doing deep learning algorithms. They have, I mean, again, with TensorFlow and Keras, I can do a lot of deep learning equation and basically put 4D modeling and all that. So again, Python, and also you even brought up AWS. I can do AWS. You can use R and too, but again, AWS, Azure, and all that to run deep learning equations and all that. I can use a Python and run it in AWS and Azure cloud system easy. So again, I don't see the difference. It is what it is, but again, but I know the libraries for Python is extensive and in depth. So again, it just depends.
All right. All right, next item on the docket is from TechCrunch. Amazon releases Kendra to solve enterprise search with AI and machine learning. Enterprise search has always been a tough nut to crack. The holy grail has always been to operate like Google, but in-house. You enter a few keywords and you get back that nearly perfect response at the top of the list of the results. The irony of trying to do search locally has been a lack of content. Sounds like some YouTubers. While Google has the universe of the World Wide Web to work with, enterprises have a much narrower set of responses. It would be easy to think that should make it easier to find the ideal response. But the fact is that it's the opposite. The more data you have, the more likely you'll find the correct document. Amazon is trying to change the enterprise search game by putting it into a more modern machine learning driven context to use today's technology to help you find that perfect response, just as you typically do on the web. Today, the company announced the general availability of Amazon Kendra. Oh, sorry. It's cloud enterprise search product that the company announced last year at AWS reInvent. It uses natural language processing to allow the user to simply ask a question. The searches across the repositories connected to the search engine to find a precise answer. Amazon Kendra reinvents enterprise search by allowing end users to search across multiple silos of data using real questions, and leverages machine learning models under the hood to understand the content of documents and the relationships between them to deliver the precise answers they seek. The company described the new service in a statement. Basically, what they're delivering to you is machine learning as a service. They're basically delivering it to you. You don't have to actually do anything. I worry about this market getting to that point. I think because it creates laziness in some people, you know. It's kind of like having Uber Eats, you know, people don't have to cook anymore. They just kind of order stuff.
It's already here. They have automated machine learning tools, so it's already here.
Yeah.
So it's not, it is here already. So but the goal again is to understand how the data works. Just plugging it in and giving you predictions and not understanding where it goes, all that, that's where the problem comes in. But it's already here.
Engineering Cannabis, you guys, people in the chat asking me some questions. All right, this is from towardsdatascience.com. Bookmark this if you are new to Python. If you are new to Python because of the boring quarantine life, congratulations, you're picking up the fastest growing major programming language. I am sure you already know some advantages of Python, like its simplicity, it's easy to learn, etc. These are also the main reasons that I learned Python 5 years ago. As I hope you can learn Python more efficiently and you can fully enjoy learning Python. Here's a list of simple but useful tricks and tips. Currently, I am using Python 3.8. If you face any problems during my following my examples, please check if this is because of your Python version.
Hey, I was going to ask Mike.
Yes, sir.
No, that's interesting that the article says that Python is easy to learn, because I was talking to someone who was in software and I was asking them, which one they thought I should learn first, and they were saying actually either C or C+, I can't remember, before Python.
That's the traditional response, right? Everybody always says, oh, C or C++. That's because in academia, that's how they teach you, right?
Oh, okay.
In academia, that's how they teach you, but in the real world, Python is quicker to learn than C++. C++ is very hard to understand. That's, in fact, C++ is becoming almost obsolete because C# and Java are ways ahead better. It's cleaner, there's less junk from a development standpoint. Part of the reason why a lot of applications run into memory exhaustion issues, right? An application may use up a lot of memory and slow the system down is because it was developed in C++. And because C++ can't dump the garbage that is put into it, it tends to hold on to it, and that expands the memory usage. And that's why you see applications run out of control on certain computers because they were just poorly, the language is kind of old for what is needed. There's a famous saying by Bill Gates, 640K kilobytes of memory. Who would need more than that? At the time that he was saying that, when they was writing applications, they wrote it specifically just for that, right? But now you have, these new systems and whatnot, 2, 4, 8, 12, 16 gigabytes of memory. Some of these applications just consume all the memory that's there because that's the way the language was designed.
Oh, okay. Wow.
Yeah, that's the way the language is designed. But with Python, the complexities of C and C++ is not there. That's why you tend to see a lot of boot camps focus around Python, because you can get it in 6 to 8 weeks. You won't be an expert, but you'll have a better understanding of it than you would of C++ or C#, or C.
Mike is not lying.
Gotcha.
Python is the easiest language I've learned, and I've learned C++ and I hated it. I've learned MATLAB and all that, but Python is easy to pick up. It's not hard at all. So anybody who tells you that Python is difficult, nah. I'd rather learn Java before. I've learned Java before. Basically, Java, it's harder, but Python is easier. Way, way easier. It's like written language. It's easy to pick up. It's easy to just write variables. It's just easy. It's not difficult at all. Especially with data science, it's not difficult at all.
Yeah, have you started learning that Renaissance man?
No, not yet. Was looking into that, and like I said, that was the standard response. Like I said, she was a software, and I think she actually was electrical, but I think she minored in software as well too. But that was the standard response, and that makes sense from what you said, what you learned in school.
Yeah, so this is a if you're a beginner, this is where this person actually structured out the learning path for learning Python. I mean, he basically just served it to you on a platter.
Okay.
So yeah, if you want to learn Python, this would be like the go-to to read over.
No, I definitely, like I said, bookmark it.
Yeah. All right, let me jump to the next item on the docket. All right, this is from technologyreview.com. Our weird behavior during the pandemic is messing with AI models. Machine learning models trained on normal behavior are showing cracks, forcing humans to step in to set them straight. In the week of April 12th to the 18th, the top 10 search terms of Amazon.com were toilet paper, face mask, hand sanitizer, paper towels, Lysol spray, Clorox wipes, mask, Lysol, mask for germ protection, and N95 mask. People weren't just searching, they were buying too, and in bulk. The majority of the people looking for masks ended up buying the new Amazon #1 bestseller, face mask pack of 50. When COVID-19 hit, we started buying things we never bought before. The shift was sudden. The mainstays of Amazon's top 10, phone cases, phone chargers, Lego, were knocked off the charts in just a few days. Nozzle, a London-based consultancy specializing in algorithmic advertising for Amazon sellers, captured the rapid change in this simple graph. It took less than a week at the end of February for the top 10 Amazon search terms in multiple countries to fill up with products related to COVID-19. You can track the spread of the pandemic by what we shop for. The items peaked first in Italy, followed by Spain, France, Canada, and the US. The UK and Germany lagged slightly behind. It's an incredible transition in the space of 5 days, says Real Klein, Nozzle CEO. The ripple effects have been seen across retail supply chains, but they have also affected artificial intelligence, causing hiccups for the algorithms that run behind the scenes in inventory management, fraud detection, marketing, and more. Machine learning models trained on normal human behavior are now finding that normal has changed and some are no longer working as they should. How bad the situation is depends on whom you talk to. According to Pactera Edge, a global AI consultancy, automation is in tailspin. Others say they are keeping a cautious eye on automated systems that are just about holding up, stepping in with a manual correction when needed. What's clear is that the pandemic has revealed how intertwined our lives are with AI, exposing a delicate codependence in which changes to our behavior change how AI works, and changes to how AI works change our behavior. This is also a reminder that human involvement in automated systems remains key. You can never sit and forget when you're in such extraordinary circumstances, says Klein. Machine learning models are designed to respond to changes, but most are also fragile. They perform badly when input data differs too much from the data they were trained on. It is a mistake to assume you can set up an AI system and walk away, says Rajiv Sharma, Global Vice President at Pactera Edge. AI is a living, breathing engine. Sharma has been talking to several companies struggling with wayward AI. One company that supplies sauces and condiments to retailers in India needed help fixing its automated inventory management system when bulk orders broke its predictive algorithms. The system sales forecast that the company relied on to reorder stock no longer matched up with what was actually selling. It was never trained on a spike like this. So the system was out of whack, says Sharma. Yeah, this is bound to happen. Okay. You had behavior that changed too frequently and too soon of a time. For the AI models or the machine learning models to really be useful. And so I guess from a consultancy standpoint, I guess you would have to build an alternative AI and machine learning model-based system to actually, a deep reinforcement learning model so that it can actually get a better understanding as to what's going on. Because with the AI should be asking, because it doesn't have that common sense, but what it should be asking is, why the sudden shift and what is happening currently?
Yeah, this this is interesting because last night, I think after you left, Mike, Complex started talking about, I believe it was the National Society for like AI implementation or something. It was basically a study, and it was basically talking about how the U.S. need to implement AI to remain competitive and hold its competitive advantage. And it was just talking about the need for it. But things like this, it'll be interesting trying to balance, a quick implementation with actually getting it right. Because it's even said in the article, like, it needs to be done, but it has to be done right. I believe Eric Schmidt said that. So.
Yeah, definitely. And what's interesting is that, you have a lot of people talking about adding AI taxes and robot taxes and stuff like that. Even if you added a tax to it, a pandemic, which would nullify any sort of use for the AI or for the robot itself if it can't adapt quick enough. I mean, I think the proper term, and I could be wrong about this, is that the AI has become autistic intelligence rather than artificial. It can't, it's out of norm, was what I'm saying. From an intelligence standpoint, it's out of norm. I don't know how you keep it. I don't know how you build a sort of contingency model so that it doesn't fall out of whack like that. So that the new data sets that do come in can be trained correctly. But like the article says, it still needs humans to set them straight. I don't see why more people aren't learning this type of stuff, even at the base level.
Yeah, because I'm sure any sort of, a pandemic, granted, based on, reports that we've received, it sounds like the government even, a year or two ago was, it was on its radar of something like this happening, but, it's still an outlier event. So it sounds like sort of any sort of outlier event that can, trigger something like that will sort of cause the system, like you said, kind of go haywire.
Mm-hmm. Mm-hmm.
So no, it kind of shows that, kind of like with anything with new technology, everyone always freaks out and thinks, oh, this is the end and, it's going to take over. But it just shows, you got to have a human there to sort of keep it from going off the tracks.
Mm-hmm. Mm-hmm. And it's going to be like that for a long time. All right. Last item on the docket is from cloudblog.google. So learn 3 in-demand cloud skills in 30 days at no cost during the month of May. Let me explain this over. In April, we announced we were expanding our Google Cloud learning resources to support growing number of people working and learning from home. Today, we are excited to announce that if you sign up by May 31st, 2020, you can still enroll in Google Cloud training on both Pluralsight and Quick Labs at no cost for 30 days. If you are new to Google Cloud, we recommend our 5-hour introductory level series of Google Cloud Essentials. These labs will give you a tour of Google Cloud and help you familiarize with basic cloud concepts such as virtual machines on Google Cloud, Google Compute Engine, containerized applications with Kubernetes engine, network load balancers, and HTTP load balancers. To get started, register here. So
They aren't the only one, I think, doing something like this. I think I saw an advertisement. Someone who has like CAD software and other things, they were
yeah,
offering it for people who were, I think it was mainly more geared towards high school kids who were out of school, but like 3D CAD and as well as a few other programs for free to learn.
mm-hmm, mm-hmm. I threw this on a document. I think it's a little bit relevant to the topic. Do some learning on machine learning. Global machine learning market is expected to grow at almost 44% from 2019 to 2025. Making these skills relevant for any technical professional, the machine learning on Google Cloud Learning Path will allow you to experiment with end-to-end machine learning, starting from building a machine learning focused strategy and progressing into model training, optimization, and production with hands-on labs with Google Cloud. The 17-hour learning path includes 5 courses with interactive hands-on labs and lectures. Anyone with knowledge of querying with SQL and programming in Python can take this learning path. So I think this is very important. I would still jump on it. I would just sign up for it if anyone's interested in getting into machine learning. Mostly because you can't go wrong with it, even if you don't understand it. Same thing with the data analytics. The data analytics on Google Cloud Learning Path helps you build these much needed skills, teaching you to explore, mine, load, visualize, and extract insights from diverse Google BigQuery data sets. You also dig deeper into data loading, querying, schema modeling, optimizing performance, query pricing, and data visualization. This 13-hour learning path includes 4 courses, which are a combination of hands-on labs and lectures. We recommend you have some prior experience with ANSI SQL before taking this learning path. Yeah, this is good for free, in my opinion. Can't go wrong with this. Machine learning and data analytics on Google Cloud. This is good stuff.
I was going to ask a little bit unrelated, but as far as the actual cloud platforms, is there someone who's really taking the lead, or
Amazon.
as you see, say again?
Amazon.
Okay, so you think AWS is?
Yeah, Amazon has always been in the lead because they were the first ones out the gate. But Microsoft is starting to catch up, and so is Google. Google is starting to catch up because Google has a lot of services that they offer that people just use commonly every day. With AWS, you got to pay for a lot of those services. And so unless you're an enterprise, you're not really going to be using AWS all that much. With Microsoft is basically a Windows shop for a lot of enterprises, a lot of small businesses. But as they move to the cloud, everybody else who's a client also have to move to the cloud. So if you use Microsoft products, it's inevitable that you have to move to the cloud too, because that's where they're going. And so that's where all of this is really starting to tie in. Oracle made some big moves this year, but they have the least amount of market share, and so does IBM now, which is why they acquired Red Hat last year, because they want to get deeper into the cloud, and that market is starting to run away from them. And so it's all dependent on what you're trying to do. You can get a general cloud certification, or just learn a lot of this stuff that's freely available. You don't really need to be certified all that much unless you plan on being a cloud engineer or something like that, or cloud architect.
Okay, but it sounds like from what you're saying though that at least Microsoft Amazon's ahead obviously, but Microsoft has a good chance of catching up because of all the suite of services they're already offering.
Well, yeah, because they want to put Windows into the cloud, which is what they're already working on. Once that's fully fleshed out, they'll blow Amazon right out of the water. The thing is, Amazon serves a purpose in some areas, and then Microsoft serves a purpose in some areas, and Google definitely serves a purpose in some areas. So it's a matter of if you want to learn cloud, you're going to have to learn all of these platforms anyways from a consultancy standpoint. From an IT standpoint, you kind of learn whatever the company's using. So if they're using AWS, you got to learn AWS. Can't focus on Google Cloud. It's really not it's not your wheelhouse.
Now, when you say actual windows to the cloud, obviously you can save documents and things like that. What someone who's like a novice like me, what is the advantage of Windows, the actual platform, being in the cloud versus just being able to save documents?
Because the operating system is they're trying to put into the cloud. Basically, it would be like streaming Netflix to your TV. They're going to try to stream Windows into your computer as well.
Oh, so less power, so not having it physically installed on your computer, and thus I'm assuming more memory and power being used, repurposed for other purposes. And plus, yeah, I'm assuming any access technically from any computer, not necessarily just your computer.
Yeah, it would be Windows as a service. Similar to how you have Netflix is a service, right? It's on-demand service. You find a movie, you queue it up, and then you run it. They'll do the same thing with Windows eventually, where you open up your Chrome browser and you'll log into Windows that way, instead of just logging into a whole computer.
I guess you could also technically go, from a business standpoint, technically go to like a short-term like subscription model type of software versus like having to just have everyone necessarily buy it. Like, you could subscribe to it for kind of like the same thing with Netflix. You can subscribe to it for 3 months and then cancel it.
Yeah, to an extent, because a lot of companies have not gotten off of Windows 7, right? So how do you get off of Windows 7 really quickly? Well, you got to kind of just pop open an account. That's what Microsoft did. So you just open up a browser, and even though you're in Windows 7, you open up a browser, you kind of just open up a virtual machine from the cloud and run your environment that way. It's a very slick way of doing business from a Microsoft standpoint. Now you don't have to send a CD or a DVD out to somebody, you have to load it up. You don't have to do any of that stuff anymore. It's just a matter of logging into it from your browser, and you're in.
I was gonna say troubleshooting too, but that's big.
Yeah,
like help desk and stuff.
Yeah, because a lot of that stuff is automated. I know Microsoft was working on machine learning for triaging incidents, like help desk stuff, like your printer is not working and stuff like that. I know they were working on that stuff back in 2016, 2015. So I can't imagine where they are now with it. So that's the kind of direction that they're going into. We're using AI and machine learning and cloud compute to get the next wave of technology down to customers. Even the whole Surface thing, Surface is just a model for where Microsoft plans on taking their operating system. A lot of people have speculated on whether or not Microsoft will push Windows down to Xbox and turn it into a home computer.
Oh, okay.
It has all the power and capabilities to do so. It's just a matter of offering it as a service.
Gotcha. Now I was going to ask too. I'm assuming this is all you would, in order, at least if you're not on a Wi-Fi connection, I'm assuming for the streaming type of service to work, you would need 5G. It's contingent on that, or?
Exactly.
Okay.
Yeah, exactly. That's where 5G becomes very relevant. It's going to be really bandwidth intensive, but that's the nature. That's the reason why you have 5G. You'll be pushing that stuff right down the pipe. And that's where I think we covered it earlier this week, but 5G applications, edge-based applications. That's what edge is the outer layer of the cloud. So rather connect all the way to the cloud, you'll connect to what they call the edge. The edge is basically the closest area to the perimeter of the environment that you can connect to. So rather, if let's say if we have the cloud server in VA for AWS, which is one of their regional sites, I don't have to connect to there. I can connect to the Massachusetts-based edge service, and I get the same results. But from a computational standpoint, everything is being processed in Massachusetts and not necessarily in VA. And so once the edge is finished with it, the edge is finished processing all this information and doing what it needs to do, and then it will ship it to VA after it's finished. But for me, being the pedestrian, I need the results as soon as possible, because I can't wait for that long travel for data to get from Massachusetts to VA. For us, from a technology standpoint, it doesn't make a whole lot of sense to us to wait. So it provides that real time or closer to real time processing of computational data and stuff like that. That's why you have IoT and 5G and stuff like that. That's all that stuff matters, in the grand scheme of things. Even from a machine learning, artificial intelligence standpoint, they're not going to wait. If the artificial intelligence was previously being done at the VA data center for AWS, they're talking about tiny AI. Tiny AI is basically AI on your phone or your iPad or even in your car. The AI is processing all that. The artificial intelligence is processing it in your hand or in your immediate location, and not waiting to process all that information at the VA data center for AWS. That's silly. That's too much time lost, and you need results now. So
that kind of goes back to what you're talking about the microchips getting better as far as redesign. Exactly.
And that's why Tesla is working on a new chip for their cars, because they need to, process information a lot faster. I mean, if you got a car that's generating all this data, the tire pressure, how many times it brakes, how much energy is in the battery, how many, what's the range left on the battery itself for the vehicle, where's the next location to charge the vehicle, what the weather is, and what the traffic level is. There's a lot of information that needs to be processed right there on the spot, and you can't wait for it to be sent out to some faraway data center. That just doesn't make any sense.
Yeah, now I was going to say too, and that's the other thing I see with all of this, us moving this direction. I see why cybersecurity is in such a demand too.
Exactly.
Because you literally have created risk in all sorts of places that previously didn't exist, as far as things people could hack and attack.
Yeah, because you think about machine learning, right? Machine learning is fed by is best trained by the data sets that it's fed. If I'm a bad guy and I want to throw the machine off, I'm going to feed it as many bad data sets as possible, or I'm going to poison, or we call data poisoning, right? If I poison the data that goes into it, it's going to give you bad results. Therefore, your machine learning model and your AI is fucking useless. Somebody has to be looking at all this, right? So that's where blockchain comes in, immutability, putting those data sets on there, feeding it down to the to the AI itself as an application. There's a lot of ways that we can go about this in terms of managing a more, secure smart city or smart society, whatever they want to call it. Because that's exactly how your traffic lights are going to be incorporated, your airports, your public transit, all that stuff has to be taken into consideration, because there's a lot of data that's being generated.
Yeah, no, absolutely.
Now, can you get certified in Python or machine learning? You can get certified in Python from Google IT certification in Python that just came out a couple months ago. You can't get certified in that. I don't think you can get certified in machine learning in AI. I think that's just all a matter of skill set. and demonstrable execution. You got to be able to execute that. Usually in a job interview, they're basically going to ask you a few questions around data science, machine learning, and AI and stuff like that. They're going to ask you an example of your work and go to the whiteboard and things like that. You can't certify in this stuff really.
Yeah, I saw Elon Musk was saying literally, I think this was a few weeks ago, he was saying, hey, if you understand artificial intelligence, I don't care if you have a degree, whatever, just, you can work for me if you know what you're doing.
Absolutely.
And it just sounds like, from the rate of change, from at least what I'm seeing, I know I'm looking at master's programs, and programs are just starting to get on board with actually creating the curriculum. Some obviously faster than others, but as far as getting up to speed on some of this stuff, so the self-taught person has kind of got an advantage. Because I know I graduated in 2013, December of 2013, and I mean the sophomores, I think they had just started like implementing a data analytics like class. They actually replaced it statistics class with data analytics, but that was it. They still didn't have like a data analytics major or anything like that, or business analytics. And I know they've since done that, but that's like I said, it'll be a little bit over 6 years since I've graduated. So that just shows you how fast the discipline has evolved.
Yeah. I think you're in Alabama, right?
DC now. Was originally in Alabama.
Yeah, I mean, all those farmlands and whatnot, agriculture, sort of industries, they need data, better data to better service their crops and their output. They don't want to, if they can track down a bad, bad meat, bad cow meat or something like that, beef, right? If they had all the data generated into a big data lake or whatever it is, and tagged all that data, and actually monitored all of those cows and stuff that they slaughter, they can trace down that bad those bad packages of meat down to the exact cow that it came from, to the cattle that it came from. And so they don't have to recall all of the meat. They just need to recall the certain packages that have been tagged with these QR codes, right? And they know it's on a blockchain, and that's all that information is shared with, the National Institute of Health and the FDA, Food and Drug Administration, and all these other agencies. They're all aware of all this type of stuff. That's the power of big data. That's the power of big data, especially if it's structured correctly.
Yeah, no, that was the first time like I'd heard of blockchain, and this is probably about 2 years ago. I think it was an NPR story. They were talking about cattle ranchers, I believe, in like Montana, and basically they had some cattle that was basically only like grass-fed, organic, and you had the other cows who had who weren't didn't fall in that category. And they were saying, initially when they sent the cows off to be butchered and slaughtered, they really couldn't charge a difference in those two because they couldn't distinguish, the cows would get mixed together, so they couldn't really distinguish which ones, and then guarantee it all the way through the supply chain. Right. And that was the example they were using for blockchain is, now, you can literally put a barcode on it and actually trace it back and know, hey, this cow came from here, and we know, it was grass-fed the whole time.
Yeah. You know who slaughtered it as well.
Yeah, exactly.
If they had COVID, you got some COVID meat coming your way, you might not want to eat that.
Yeah, exactly. So yeah, it was saying that. And then another guy, I actually was at a conference, and he had like a software like consulting type of company. He used to work for IBM, and he was talking about blockchain. He was saying there is so many uses for it. He was saying one of the things they were focusing on was like luxury goods in Europe and the counterfeiters. So trying to implement some solutions there.
Oh yeah, you put a lot of these goods, Gucci, and they already have a blockchain for it. They came out with that. They came out with that last year, and so all of these knockoff bags and stuff coming out of China, they won't have any value if the people who do own the authentic items know exactly where their bags and stuff came from, the purses and stuff came from, and so that's going to increase the value triple, because if I can verify the authenticity of this item, anything that can't be authenticated, it has no value. It'd be worth $5 or $10 at best. And then people are not going to want it because they want the most authentic item, even if they have to put it on layaway and sacrifice their well-being. They will, at least for the other gender, they will do it. That other gender, they tend to, they'll go days without eating if it means getting that, those red bottoms. So
I was gonna say, if you with guys, you're talking about Air Jordan tennis shoes.
mm-hmm.
StockX is essentially, tried to implement some sort of, method for authentication and resale, but like you said, blockchain there, that'll
mm-hmm.
put some of these, because they've gotten pretty good at counterfeiting shoes.
Yeah. I don't buy those shoes, but I can see where the where that would matter. I can definitely see where that would matter. So, I mean, I've talked about this before, being facetious, but I'm being serious about it. That you start talking about reparations, and feasibility studies and whatnot. All of this information, all this data that's being gathered through genealogy and genetics and stuff like that. All this stuff can be put on the blockchain and be served right to the government. Government wants access to it to verify that this person is a descendant of slavery, and wants their reparations. That can be done. That could be done in less than a year. There's only so many few people right now in Black America that could actually make that claim. But for those who can claim it, you can actually develop a information architecture around it. I mean, you got a museum in Washington, D.C. based on slavery. I mean, these people are debating on whether or not people should be compensated for their misery and their losses.
Yeah, no, that very good point, because something like that gets out, everyone under the sun. You got Elizabeth Warren saying she's Native American, so it wouldn't surprise me if she's some black ancestry as well too.
Well, yeah, the Native Americans here are not fond of her at all. She does not have any support. That's probably the reason why she lost the Biden. But had they put their genealogy on the blockchain or something like that, where everybody can look at it and everybody can verify it, she wouldn't have been able to make that claim. I mean, she was better off just like driving off in a Jeep Grand Cherokee or something like that and saying, "Oh, I made a mistake," She was better off saying, "Now I'm referring to this right here," And she benefited from it, right? She benefited from it. She should pay all that money back that she did accrue from it, But that's the power of data in tracking, contact tracing and stuff like that. That stuff matters, There's a lot of opportunity that can come out of AI, ML, DL, and stuff like that, data science. Somebody needs to do that, but we don't have a working institution that works to that mechanism, so to speak, the legal mechanism, or even a social mechanism that says, for African Americans, descendants of slaves, this sort of system we're going to design, and we're going to create this sort of connectivity between government agencies and the people, the descendants of the slaves themselves, and now we can have a working ethics model as to how this should go about. All these people that will show up later, like you're saying, they will be null and void, right? Even Ben Affleck, as much as he wants to hide his little history, he wouldn't be able to be compensated all that well, since most of these people don't know what their fathers are.
Yeah, no, one other thing that popped in my head with data science, like originally with studying it too, was I know like with workplaces and the big push for like diversity and inclusion and all of that, you know, I'm sure you can look at pretty much say, you know, you got companies that, you know, say they're diverse and open and all of that. You know, you can sort of say, okay, give us all your, you know, your promotion data for the year, or, you know, give us, you know, your hiring trends, or, you know, all the people who actually applied for this job were interviewed, and then your end result as far as pool of applicants. And, you know, with that sort of data set, you can sort of, you know, see where the trends are. Okay, you know, this department has a trend of not hiring minorities in it, or, you know, this manager does really good. This, you know, all that's basically available to you. Now, I'm sure, you know, HR would freak out about that data getting out. But, you know, that's something even internally that you have as a tool.
No, if you're a publicly traded company and you take tax incentives in certain locales, right, in predominantly mixed or predominantly non-white areas, and you don't create, and you don't comply with the measures that you're supposed to be complying with in terms of like creating social equity and stuff like that. Yeah, we should be tracing all this stuff on the blockchain and leveraging all this data and all this technology that at our fingertips. Why should the company, take up a large footprint within a major city and have a predominantly white workforce, and then tell everybody else, pull yourself up by your bootstrap, while they take the very incentives that that were doled out to them to hire the other demographics, right? For diversity and inclusion. They don't really want to get to that point, because if they do, they won't be able to meet that quota. They will never be able to meet that quota. In fact, what they'll do is they'll hire more Indians or something like that to come on, to their workforce and say, look all the diversity that we have. Indian women and Indian men. Look how diverse we are. We have brown people all over the place.
But yeah, you can even still blow that narrative up, because I mean, if you're tracking by groups going down to, okay, you got this many black men that your company has an issue with discrimination against black men, because you look at the applicant pool and you look at how often they're hired versus how often someone else is hired. Mm-hmm. So I mean, like I said, it's a matter of, can you get access to that data? But it kind of goes back. Wait, say again.
LinkedIn has it. LinkedIn has a one-click job application apply, right?
That's true.
On their site, right? So any company that posts a job on LinkedIn, you can click apply with one button by submitting your profile to that company for that job. They have that information. Is LinkedIn going to release you that information? Microsoft owns it now, so maybe things might be different. Might be very different. Even Microsoft still has this problem with less than 10% of its workforce being of African American descent. Still has this problem.
No, go ahead.
No, go ahead.
No, I was going to say it kind of go that, as well as it kind of plays to, I know obviously it wasn't popular, but with AOC and the whole Amazon fiasco, but I did think she didn't handle it the best, obviously, because they moved their headquarters. But I think she did make a point in the sense that, if you're going to relocate to New York, you need to actually be able to demonstrate that, hey, the citizens here are going to actually have a shot to get some of these jobs and, better themselves, versus we're going to put this big headquarters in New York. It's going to drive the cost of living up. And then we're going to bring, all these high paying jobs for people from all around the country who are going to migrate here and push out the people who are here, who voted to bring you here in the first place.
Mm-hmm.
So another application there.
Yeah, absolutely. The thing is, we're not all on the same page in terms of like black people in the these big corporations. And so one black person gets inside this corporation, they close the door on you and say, oh, well, I'm good. I don't need to fight for anybody anymore. I got in here and I'm good now.
Yeah.
And that becomes a narrative. And that becomes unfortunate, because they'll use that one person to say how much diversity they have. They create these sort of digital marketing, advertisements. You always show this random black person who nobody knows anything about, what looks so happy in the picture, and it doesn't even work for the company. It's unrealistic, man. So it's unreal. So the way how I see it is that some of these nonprofits and think tanks do keep track of a lot of this stuff. I don't know how they do it, but they do keep track of it. That's how we were able to figure out less than 10% of most of these Silicon Valley companies are African American. In fact, there was a brother that worked for Facebook who came out and told the story about it. You know, Facebook's employee makeup doesn't reflect its user base. So if Black people are using Facebook at an astronomical rate, you would think that the very people that use it the most would actually work there too, but they don't have that sort of reflection. And so that's why that guy kind of snapped off and then left and quit. But you know, I've heard about this before about companies having high turnover rates because high turnover rates of African Americans and not really understanding, you know, the justification behind it. What's the context behind it? Well, a lot of racism in there. You know, Silicon Valley, as liberal as it is, does have a lot of racism in it. And no one really wants to see, no one really wants to admit to it though, at least on that side, the ones who benefit the most.
Oh, sometimes it's obvious. I mean, my company back in when I started my company out of Georgia, back in Atlanta, I mean, I'll never forget, I heard a stat from someone in HR, and they said like they hired like 38% of their hires were like minority, and like 41% of their turnover was minority. So it was like, you know, you're losing ground.
Yeah.
And it's like, oh, you know, you're just sort of sitting there like, okay, man, what are you gonna do here? And they're like, okay, we gotta do better. You're just like, okay, like they don't get it.
Yeah. Yeah, Dell's been trying to figure this out for a while now. I think they're doing a fairly decent job now, from what I've heard. But I remember back in 2015, this was a major push for them with the whole diversity and inclusion thing. They wanted more Black people there. It's those who are above the C-suite are saying, yeah, you know, on the cover of you know, CIO magazine and these other magazine publications, they're saying, yeah, we're pushing for diversity. But what happens at the below the HR level, that doesn't happen, right? It's not reflective at all. And there's no real way to really measure it. But now with LinkedIn's one click button to apply to a job, single click apply, they should be able to know about what the call, you know, what the return rate is on that.
Or even if you have AI too, if you start having it, you know, reviewing resumes, you know, you may go to, hey, instead of this hiring manager picking their resume pool, here are the best candidates based on the software, and then you choose.
Mm-hmm.
So numerous options out there.
No, it's a disgrace that they would do something like that. That they would never really reveal all these numbers and stuff like that, because it's an embarrassment to them. The same country, same companies talking about diversity and inclusion don't actually own up to their own practices. Just don't do it. You know, all of the tech companies have this issue. All of them. Not one of them can escape or walk away with their hands clean and say, we don't have this problem. Yeah, you have this problem. You have this problem. You can look at the numbers.
Yeah, no, it'll be interesting too if it's a generational thing, in the sense of you seeing boomers retire. I know I was listening to my CFO talk the other day, and he was saying the majority of the company is now millennials. So it'll be interesting if it's like a generational thing where it's like, you know, baby boomers, you know, you still have that element of legalized discrimination of people who grew up in that time, versus if it's sort of, you know, if it sort of levels out a little bit with younger people and more educated millennials, or if you know it continues to be an issue, because you know when you start looking at kids who are like, you know, 6, 7, 8 years old, you know, the majority of them are minorities. So it's like at some point you're gonna have to like something's gonna have to give, because I mean you're not gonna be able to go, you know, 20 years from now and have, you know, a corporate entities that, you know, that look like they do now. It's just not going to play out well.
Well, no, they'll just hire more Indians. That's what they'll do. I mean, if you look at IBM, Google, and Microsoft, they all went out specifically and did what? They got Indian CEOs to run their companies. Even Oracle, not Oracle, I forget the name of the company now, but basically those three companies replaced all their white CEOs with Indians. I mean, you never really hear too much about Xerox and
They had a black woman.
Yeah, she's been with the company for 30 years. She didn't get, she started there in the 1980s. It's an electrical engineer. So she's the CEO of the company. You never really hear. I think her name's Ursula Burns or something like that.
Yep, that sounds right.
Yeah, you never really hear much about, about her dealings with the company. I mean, she's been on like the cover of like Essence and all that stuff, but she's never been at the forefront of diversity and inclusion discussion. And so, especially when it comes to emerging technology like AI and stuff like that, you would think that they would be more vocal about it. But like I said before, they get their bag and they're good, man. they don't care about anybody.
Yeah, No, I was surprised when you said Microsoft, because I know the chairman of their board is a black man, John Thompson.
Mm-hmm.
So I figured there'd be some, if you're on a board of directors at that point, it's like, if you can't speak your mind then, when are you ever going to get someone? Because I mean, board of directors, it's a sweet gig, and he has his own company too, so another company of his own. So
yeah, I think what's going to eventually happen or need to happen is that you're going to have Black people have to create their own startups. You just can't rely on these big corporations, these big tech corporations to actually play by the rules of diversity and inclusion. Diversity and inclusion is just a smokescreen for, leave us alone, in terms of stop talking about this, interracial issue, right? So I think what's going to happen is that there's going to have to be some federal dollars to subsidize some of these tech startups, in predominantly Black areas. It's unfortunate that, these stimulus packages are going to these big corporations. They're taking advantage of 10 million, 50 million and stuff like that. A lot of that money, if that money was doled out to predominantly Black areas to create their own startups, you would see a radical shift in the industry as a whole. I think they know that, though. I honestly think they know that would happen, and they'll do whatever they can to, sabotage any funding from the federal government. I think they know that. That's the only way I can think of to address this diversity and inclusion issue. You can't force the companies to comply. If you can't force them to comply, then we'll just build our own startups and then tell you to go screw. How about that? And then we'll create these sort of tech incubators in predominantly Black areas so that you don't have this continuous brain drain of sending your best talent to Silicon Valley to get their ideas stolen by some yo-yo at another corporation. And plus, your best way to address this startup, this tech issue and this diversity issue, is to fix the environment that you live in. What better way to solve a lot of these issues of poverty than to leverage the tech that's available and have the people who live in that environment actually come up with their own solutions? I don't see why this is even a challenge.
No, that's definitely the way to go.
Yeah, there's no reason why some of these big corporations are taking, the Lakers taking $4 million and all these other, organizations and stuff like that taking $10 million from, stimulus funding that they don't need. And then, we're just going to give it back. Why did you take it in the first place? That's my question. Why did you take it in the first place? And why is that money only available during the crisis, but not available during a peacetime? So these are ideas that, people, should be thinking a little bit a more deeper level on, but I don't know, that's just my perspective, being in the tech industry for the last 15 years, man. I massive levels of racism in these areas. And this is coming from the nerds. This isn't even coming from your right wing, anything like that. These are supposed to be liberal people, but they exhibit the same levels of racism that maybe they will blame on the right.
Oh yeah, I was gonna say, yeah, you're up in Massachusetts, right?
Yep.
Yeah, that's at least, you know, stereotypically that was the place you at least expected. So
What do you mean?
Just you know, the Northeast has always, you know, presented itself as being more liberal, you know, a little bit more opportunity for Black people who have moved there,
Yeah.
versus other areas of the country, you know, West Coast as well.
Yeah, they're liberal, you know, with their rainbow flags, but they got a tiki torch on the other hand. That's pretty much their idea of liberalism, you know, rainbow flags and tiki torches.
Crazy.
Yeah. Yeah, but thank you all for joining us, man. Hit the like button, and thanks to Renaissance for sticking around and helping me out in the panel. Shalom.